Hey students, welcome back. I hope all is going well. I hope chemistry is going well for you. I hope your other classes are going well for you. Today we're talking about the combined gas law. So it's page 19. We're looking at the combined gas law and today's date is 4/7. Alright, so real quickly, the combined gas law actually brings together a couple of things that we've already been working on. We talked about Boyle's law, right? Which was P1V1 equals P2 V2. And we talked about Charles' law, which was our relationship between volume and temperature, and that was V1 over T1 equals V2 over T2. Well, our combined gas law turns out that's all we need to know, is we're just going to combine those two together into one handy-dandy formula. But before we do that, let's talk about standard temperature and pressure, or STP. This is something you're going to see in your notes, in your homework, and so it's something we need to know. So the important thing here, STP is, sorry to blow that up on you, STP is 1 atmosphere of pressure. And that could be any of those standard atmospheric pressure. Standard atmospheric pressure is 1 atm, so that could also be like 760 mmHg, 101.325 kilopascals. And then our standard temperature is 0 degrees Celsius. So that is like 273 Kelvin. All right. So this is what we need to know because some of our problems will ask about standard temperature and pressure. And so we have that little thing in our mind. So we'll want to star this and remember this for later because it's something we're going to use from here until the end of gas laws. So going back to that Boyle's and Charles's law, if we just slide Boyle's and Charles' law together, we get the combined gas law, which is technically all we need to remember. So if we look, sliding Charles and Boyle's together, we get P1V1 over T1 equals P2V2 over T2. Very simply, this is the only formula you need to know for all these, because if we have a situation where the pressures stay constant, look, we just cross it out and we have Charles's law. All right? Or if we have a situation where the volumes stay constant, we cross those out and we have P1 over T1 equals P2 over T2. So this is very handy. This is the only formula we need to know. So I would star this one as well, but the one we're going to use is probably this one down here, the one that's already rearranged for us. P1 V1 T2 is equal to P2 V2 T1. And remember, all of our temperatures need to be in Kelvin. All right, so let's jump right into a couple of examples and see what we got here. So this one is going to be, we're using that formula P1 V1 T2 equals P2 V2 T1. So if we look here, we have a 9-liter sample, 9 liters. That's a volume, so that's the first volume I see. I'm going to assign V1. Has a pressure of, there's P1, at a temperature of, there's T1. If the temperature is raised to 107, that's T2, and the volume expands to, we got a volume, what is our new pressure in ATM? All right, so we're looking for P2 as our question. So again, just like I encouraged you with Charles' law, I encourage you to write what you know out here to the right, or to the left, so that way you keep it all in order and we can stay with this T2 and T1 on the right side. So P1, we know, is 117 kilopascals. V1 is equal to 9.00 liters. T2, this is our second temperature, that's at 107, so we're going to say 107 degrees C, and we're going to add 273.15, because we remember we need to be in Kelvin there. So we're going to take 107 plus 273.15, this will tell us our temperature in Kelvin, 380.15 Kelvin. P2 is what we're looking for, that's our question mark. V2 is 17.00 liters, and T1, our initial temperature, is that negative 25 degrees C, and we're going to add 273.15 to that. So we've got negative 25, and then we're adding 273.15 to it, which gives us 248.15. Give you a second to catch up there. All right, and remember the formula we're using, P1 V1 equals Miss Griffith forgot the T in there. P1 V1 T2 is equal to P2 V2 T1. And now we're just going to plug these babies and solve. That's why we did all that work ahead of time. So we're going to put 117 times 9 times our temperature, which is 380.15, which is equal to P2, that's what we're looking for. We have V2, which is 17.00, and our initial temperature is 248. I'm going to move this just a little bit, 0.15. All right, so now we're ready to solve, and we have to isolate P2. We're going to do that by dividing each side by 17 and 248.15. So we're going to divide each side by 17 and 248.15. And this will be P2. So we're going to take 117 times 9 times 380.15. And we're going to divide by 17 times 248.15. And this will be our answer in pressure, but it'll be kPa, so we're going to have to do a little extra work. So we've got 117 times 9 times 380.15. We're going to divide that by 17, and we're going to divide it by 248.15. So the number we get right there is 94.8899. And that's kPa. But we need to take that kPa to atmospheres. We're supposed to be in atmospheres. Our answer is supposed to be in atmospheres. So this just goes back to day one. All right? So we're going to take 94.8899, and that's kPa. And we've got 101.325 kPa. This is from the back of our periodic table, is equal to 1 ATM. So we're going to divide that by that number that we got on our calculator, and just go ahead and type in, right? Divide by 101.325. And our answer in ATM with 3 sig figs is 0.936 ATM. All right? Okay, let's try one more. This one will be maybe a little less inclusive. All right? Okay, reading through. We have a sample of gas at 47 degrees Celsius. That's T1. 1.03 ATM. Well, that's a pressure, so we're going to signify that P1. Occupies a volume of 2.20 liters. That's V1. What volume, this time we're looking for volume, would this gas occupy at T2, 107, and 0.789 ATM? P2. All right, so again, I encourage you to write this to the left. What we know, P1 is 1.03 ATM. V1, 2.20. T2 is 107. And we've got to add 273.15 to that. We've got to add Kelvin to that. So we're going to take 107 plus 273.15. We're going to get 380.15 Kelvin. P2 is our 0.789 ATM. V2 is our question mark. And T1, our initial temperature, is 47 degrees C. We've got to add 273.15 to that, which will give us our Kelvin. So we've got 47 plus 273.15. This gives us 320.15 Kelvin. Now we're ready to plug this baby in. Remember our formula, P1 V1 T2 equals P2 V2 T1. And now all we have to do is plug all these babies in. 1.03 times 2.20 times 380.15 equals 0.789 times volume 2, which is what we're looking for, times our temperature, which is 320.15. Whew. All right, isolating V2, just like we did last time, we're going to divide each side by those numbers to get the variable by itself. Divide by 0.789 and 320.15. So dividing each side by 0.789 and 320.15. And this will be our volume 2. We've got 1.03 times 2.20 times 380.15. And we're going to divide that by 0.789 and 320.15. So 1.03 times 2.2 times 380.15 divide by 0.789 divide by 320.15, and our volume comes out to be, with 3 sig figs, because there are 3 there, we're going to say 3.41 liters. And that is it. We are done. Whoa, that moved on me. Alright, hope that makes sense. Thanks. If you have questions, remember, always email. Thanks, bye.